Good day, this is Bennett, also known as Jeremiah. Today we're going to talk about the difference between galvanic cell and electrolytic cells. So I'm going to deal with the main differences that are going to be important for answering questions. I'm also going to deal with a common mistake that prevents a lot of students from getting marks in this topic. If you're interested in more videos including deeper explanation and past papers, the playlist is found at the end of this video. It is also found right here on the top right of the screen at the suggested video. So let's begin. So let's start with the obvious difference. This side I'm just going to put the electrolytic cell, and then on this side I'm going to put the galvanic cell. So the first obvious difference is that electrolytic cell has got one beaker, right? So we've got two electrodes placed inside one beaker. So these are the obvious difference. So I'm going to go deeper. So then a galvanic cell is placed in two separate beakers, right? So we've got an electrode inside one beaker and another electrode inside another beaker, and it's separated by a salt bridge. So if they ask you, name one component that shows that this is a galvanic cell, we can talk about a salt bridge, right? So what makes it a galvanic cell is a salt bridge. It's also the fact that it's separated by two beakers, or rather two beakers. We've got two beakers, right? So two separate beakers, but this one we've got one beaker. So another difference that is kind of obvious is that electrolytic cell converts electrical energy to mechanical energy. So the fact that we've got a battery here shows that we already have electrical energy. So we're using that electrical energy to produce a chemical reaction. So electrical to chemical. And So a galvanic cell converts chemical energy to electrical energy. So what I want you to understand about a galvanic cell is that a galvanic cell is actually a battery. So it it converts chemical energy to electrical energy. So this chemical reaction has to be able to happen on its own so that it can produce electrical energy. So this is going to be like an external circuit. So this is a shortened version of external circuit. So remember, galvanic cell is a battery, right? We use the chemical energy inside the battery so that we can get electrical energy. So now, because these reactions can happen on its own, it needs electrical energy so that it can happen. It means this reaction is non-spontaneous, right? It cannot happen without an interference of energy. So because this this chemical part cannot happen on its own, we call this a non-spontaneous, right? So non-spontaneous reaction. So non-spontaneous. Now the galvanic part, it has to provide us with electrical energy. So because it has to provide us with electrical energy, the chemical part must be able to happen on its own. Think of it, whenever you've got a battery, you don't do anything to the battery for it to work. All you do is just to connect it, and then we immediately have electrical energy. That's because the chemical part of it happens on its own. So we don't need to open the battery and do something for it to work, right? It just happens on its own. So it means that the reaction must be spontaneous, right? So this must be spontaneous. So this thing, you don't really have to cram it. It's just about understanding the fact that this chemical reaction cannot happen except if there's electrical energy shows that this is non-spontaneous. And this part, because it's a battery on its own, the chemical part has to be natural. The reactions have to happen naturally, right? So it has to be spontaneous. And then we can also talk about whether it's endothermic or exothermic. So the electrolytic cell is endothermic. Notice that endothermic reaction usually need heat or light, right? So the electrolytic cell cannot happen on the chemical part of the electrolytic cell cannot happen on its own. It needs an interference of energy, right? So energy needs to be added for the reaction to happen. So therefore, this is going to be an endothermic reaction. So now this is just us using understanding, right? And then this part, because the reactions happen on its own, right? They don't need any interference. This will be exothermic reactions, right? So exothermic reactions don't need any energy for them to happen. They usually just happen on its own and they release energy by themselves, right? So this is going to be exothermic reaction. So this is exothermic. So I'm still going to get to the main thing that prevents students from getting marks.
Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement.
So another thing we need to talk about is the EMF. Notice that this is a battery, right? Whenever you look at a battery, the EMF is always positive, right? Whenever we're dealing with it in paper 1 in electricity, notice that we have never had a negative EMF. The EMF is always positive. So because the EMF is always positive, because we've seen the EMF always positive for galvanic cell, it's easy to memorize that galvanic cell, the EMF is always positive, right? But in the electrolytic cell, it's going to be opposite. The EMF is always negative. So whenever you're calculating the EMF for electrolytic cell, if you get a positive answer, you know there is something wrong. And then here, the other way around, if you get a negative answer, you know there's something wrong. So we know that the EMF for both of them is equals to the cathode, the energy of the cathode, right, minus the energy of the anode. So whenever we're using the electrolytic cell, our answer must be negative. Whenever we're using the galvanic cell, our answer must be positive. Now let's talk about something very serious. A lot of students actually memorize anode as positive, right? They usually memorize anode as positive and cathode as negative. But this actually depends on the situation. It is not always true. So this is where the mistake comes in. And it's not emphasized by a lot of teachers, right? Because they don't have time, they're under pressure. I was once a lecturer, I know how it feels like. So it really depends. Now what you must know is that in the electrolytic cell, it is just like we have memorized, right? In the electrolytic cell, the anode is positive and the cathode is negative, right? But now in the galvanic cell, the cathode is actually positive and the anode is negative. It's going to be very important, right? So memorize this. So in the electrolytic cell, the anode is positive, the cathode is negative. In the galvanic cell, the cathode is positive, the anode is negative. So let me show you something in the electrode potential table. Let's just say we're comparing Na and Cl, right? So in both cases, we want to find out which one is the anode, which one is the cathode. So let me show you something. Alright, just before we continue, if you're interested in knowing the prices of the tutorials, the video that contains the prices and the updated contact details just in case these ones have changed is found at the end of this video. So we're comparing sodium and chlorine, right? So we want to figure out which one is the anode and which one is the cathode in both the electrolytic cell and the galvanic cell. So notice that sodium is over here, right, with an electrode potential of negative 2.71. So whether you use table 4b or 4a, you should get the same result, right? The method that I'm going to show you applies to both of them, right? So right now I'm just using table 4b, but even if you use table 4a, which is above here, right, this is table 4a. So even if you use table 4a, the method is going to be the same. So what I'm going to mention applies also to table 4a. So we found the electrode potential of sodium. So now we're looking for chlorine. So where is chlorine? Alright, here is chlorine with an electrode potential of 1.36, right? So here is the thing. When it comes to a galvanic cell, so this method is going to be very important for the galvanic cell. With the electrolytic cell, it's not a must to use this method. So with the galvanic cell, the one that is more negative is the anode. What do I mean? This one has an electrode potential of 1.36 and the other one has an electrode potential of negative 2.71. So therefore it is more negative, right? So therefore it means Na would have been the anode if this is the galvanic cell. So let me just show you one more example. Let's say we're instead comparing Na with aluminium, right? So we're comparing sodium with aluminium. So aluminium has an electrode potential of negative 1.36. So now they ask you, let's say you want to find out which one is the anode. So in a galvanic cell, the one that is more negative is the anode. So notice that this is negative 1.66 and this is negative 2.71. So the one that is more negative is negative 2.71 because it is bigger in the negative direction. So the more negative one is the anode. So this works perfectly well for the galvanic cell. But now, when it comes to the electrolytic cell, right, you can use the method that we just did before when we have got electrodes, knowing which one is positive and which one is negative, and the positive attracts the negative ions, right, and the negative one will attract the positive ions. So what we did before, right? Or you can use this method. So in a galvanic cell, the one that is more negative is the anode. But in an electrolytic cell, the one that is more positive is the anode this time. So notice that Na is negative, right? So the electrode potential is negative, right? But now Cl has got a positive electrode potential. So the one that is more positive is the anode. So because we're now looking at an electrolytic cell, this will become the anode. So that's how it is. It is very different when it comes to electrolytic cells and galvanic cells. In a galvanic cell, the one that is more negative is the anode. But in an electrolytic cell, the one that is more positive is the anode. So let's just say this is an electrolytic cell, right? So if it is an electrolytic cell, the one that is more positive will be the anode. So let's just say this is the anode, right? So if it is the anode, how do you write down this reaction? So there is always a building up in there. There is rather always a breaking down in the anode. Remember, right? Whenever we've got the anode, as the reaction proceeds, there is always going to be a breaking down. There is always a loss in mass in the anode, right? The anode always breaks down. So, meaning that it was one thing before, but it broke down, it became many. So, meaning that you write it from right to left, right? So, it was one and then it became many. So, it's easy to memorize it that way, right? So, meaning that you write this first and then you write this. So, I'm going to demonstrate it just now. But let's just say it was a galvanic cell. If it was a galvanic cell, the one that is more negative is the anode, meaning that this one would have been the cathode. So, it means that in the cathode, remember there is a building up in the cathode. Mass is always gained at the cathode. So, meaning that we've got two separate things that will join and become one because there is a building up, meaning that you will write it from left to right as normal. So, I hope you get it. So, there is a building up, so two things will join and become one, right? So, that is the cathode. So, let me just demonstrate this part. So, this was the original way in which it was written, right? So because this is the anode, there is a breaking down, right? So remember, at the anode, there is a breaking down, right? So this breaks down. So it's what you're going to use to memorize how you must write this. So notice that it is one thing, but now it breaks down, right? So there is a breaking down at the anode. So meaning that you're going to write it from right to left so that it can be one thing and becomes many because of the breaking down. So meaning that you're going to say 2Cl, right? So notice I'm starting with this side. It's going to produce, so now you write only one arrow, right? Instead of two arrows. So it will produce Cl2 gas plus 2E minus. So that's how it is. But if this was the cathode, then it means that the cathode, there is a building up, right? Remember, originally we have something perfect like that, but then they start becoming a build up, right? So it means that it's going to be many things that becomes one, right? So there is a building up, so these two will join to become one thing. So meaning that you would have written it this direction, but with one arrow, right? So that's how it is. So in the next video, I'm going to go deeper in the applications of electrolytic cells.
Alright, we have reached the end of this video. I have included a playlist of similar type of questions. If you enjoyed this video, please like the video and subscribe to my channel. Any questions you've got or any video you want me to create, please comment below. See you in the next video.